You've probably seen a massive concrete mixer pulling up to a construction site. Its drum begins to rotate slowly, and a thick stream of concrete pours out of the wide chute. In that moment, you can't help but wonder, what is actually happening inside that heavy cylinder? How does it hold the mix? Why doesn't the concrete harden on the way? And what makes this entire mechanism work so seamlessly? Now, we're going to break down the design of a concrete mixer, the journey of the mix from the plant to the pour, and the tricks known only to specialists. But before the concrete ever enters the drum, it has to be prepared correctly. This isn't just a by-eye mixture, it's ready-mix concrete, which undergoes precise dosing at a batching plant. First, the cement is loaded, not from ordinary bags, but from massive industrial silos. Then, strictly calculated amounts of sand and gravel are added. These aggregates make up about 70% of the future volume and are responsible for the material's ultimate strength. After mixing, water is added, triggering a chemical reaction called hydration. The mixture begins to gradually harden. From this second on, the countdown starts. The finished concrete passes through a dispenser into the mixer's charging hopper. This method is called wet batching, and after this, the machine is fully ready for work. Once loaded, one of the most critical stages begins: transportation. While the truck is moving, the drum must never stop. If it stops, the concrete immediately segregates. Heavy gravel sinks to the bottom, while cement paste rises to the top. This is why the drum is always rotating, even if the truck is stuck in traffic. During transport, it makes about 3 to 5 revolutions per minute. This is enough to keep the mixture homogeneous. There are challenges along the way: traffic jams and steep inclines. When the truck climbs a hill, it looks like the concrete could easily spill out. To prevent this, the driver increases the RPM. It's important to understand, it's not centrifugal force at work here, but the geometry of the internal blades. As the rotation speeds up, they actively scoop the mixture and push it deeper toward the base of the drum, keeping the load inside even on steep slopes. Inside the drum are massive spiral ribs, an Archimedes screw. When the drum rotates in one direction, they mix the concrete and keep it inside. If the rotation is reversed, the spiral begins to act like a conveyor, lifting the mixture and pushing it out. In cases where the mixer cannot get close enough to the site, a concrete bucket, or skip, is used. The mixer discharges the mix directly into it, and a construction crane lifts the container to the required height. Working with a bucket requires surgical precision because concrete is incredibly heavy, and any sudden movement can lead to an accident. The bottom discharge gate of the bucket is opened manually. The operator simply pulls a side cable or lever. The drum itself is a masterpiece of industrial welding. Production begins by passing thick sheets of wear-resistant steel through powerful rollers, bending them into sections. The parts are then welded by automated systems to ensure perfect airtightness. The finished structure is mounted on the chassis at an angle of 10 to 15 degrees. A key feature is that the drum is not mounted rigidly. It's attached via special dampers or spring-loaded connections. This system absorbs vibrations, relieves excess stress from the frame, and prevents the formation of fatigue cracks in the metal. It is vital to remember, the drum should never be filled to the brim. There are 2 reasons. First, the immense weight. The density of wet concrete is about 2.4 to 2.5 tons per cubic meter. A drum with a standard geometric volume of 12 to 14 cubes can physically carry no more than 8 to 10 cubes of mix. Otherwise, the total mass will exceed the allowable loads on the axles and bridges. The second reason is stability. An overfilled drum critically raises the machine's center of gravity. On an uneven road or in a turn, even a small pothole is enough to cause the multi-ton machine to instantly flip onto its side. To ensure such a heavy drum rotates smoothly and stays under full control, a powerful hydraulic drive system is used. This system maintains the continuous motion required to prevent the mixture inside from immediately segregating. The heart of this system is the hydraulic motor, mounted at the front of the drum just behind the truck cab. The process begins with a hydraulic pump, which is powered by the diesel engine via a power takeoff (PTO) shaft. This pump forces oil at high pressure into the hydraulic motor, causing it to spin. A crucial technical detail: the hydraulic motor is not connected directly to the drum. The transfer of torque happens through a massive planetary gearbox. This gear system performs a critical task. It drastically reduces the rotation speed while colossally increasing the turning force. To put it simply, The motor spins fast but with relatively low torque, and the gearbox converts that motion into a slow but unstoppable rotation, capable of turning 20 tons of viscous concrete. In demonstration clips, this is clearly visible. The drive shaft spins briskly, while the drum itself moves slowly and steadily. To protect the structure from destructive vibrations, rubber damping pads are installed under the front drum support. These pads absorb small shocks and protect the truck frame from fatigue stress. On the sides of the rear section of the drum, steel support rollers are installed. They bear the immense weight of the structure, reduce friction, and ensure rotational stability even under a maximum load. The hydraulic system has its own Achilles heel: oil overheating. During intense operation, the oil gets very hot, which can lead to drive failure. To prevent this, an oil cooler with a powerful fan is mounted on the frame to dissipate excess heat into the atmosphere. Control of this entire system is located on a side panel or inside the cab. Levers and joysticks allow the operator to change the direction of rotation, clockwise for mixing and holding the load, or counterclockwise for discharging. However, sometimes the worst happens. The drum seizes, often called the concrete trap. If the mixture is not discharged in time, or if the drive fails while stuck in traffic, the concrete hardens right inside the drum. This turns the mixer into one of the most expensive problems on a construction site. To remove the hardened monolith, the drum must be cleaned manually. A person has to climb inside through a special technological manhole on the side of the drum. In extreme cases, where the concrete has filled most of the volume, micro-explosion methods are used. Specialists set small, shaped charges to shatter the monolith without rupturing the steel shell. This is a dangerous and costly procedure that operators try to avoid at all costs. Now let's move on to another system that not everyone knows about: the pressurized water circuit. A concrete mixer is equipped with its own tank, typically holding about 400 to 600 liters. This water is used in two main scenarios. First, to slightly adjust the workability of the mix if it's too stiff for pouring, though this is strictly regulated. And second, to thoroughly wash the drum and chutes before returning to the plant. When you see neat concrete cylinders near a mixer, those aren't waste. They are control samples cast from the same batch as the main pour. They are left on site to begin curing under real-world conditions and are later sent to a lab for compression strength testing. Before testing, the samples are cured in a controlled environment to ensure the concrete reaches its design strength, usually at the 28-day mark. Then, the cylinder is placed under a hydraulic press that gradually increases the load. You can see the pressure rise until the first cracks appear. Depending on the mix, the sample either shears along a single line or shatters. Experts analyze the failure pattern and compare it against standards to ensure the concrete on site meets the structural requirements. Now, a bit about safety. A concrete mixer must only stand on solid ground, especially if the surface isn't reinforced. There are many cases where a truck gets too close to the edge of an excavation, and under a 40-ton load, the ground simply gives way, sending the entire vehicle into the pit. For such heavy machinery, any loss of stability can result in an instant rollover. There are other types of mixers as well. Some models, designed for smaller jobs, are self-loading mixers. These machines are equipped with their own loading bucket and can scoop up sand, cement, and gravel themselves, mixing the concrete on the go. There are also hybrid models with built-in pumps, conveyors, or booms. They carry less concrete, but are perfect for sites where there isn't enough space for two separate machines. Essentially, it's a mixer and a concrete pump in one body. And now the big question: which is better, ordering a concrete truck or mixing it all by hand? Let me know your thoughts in the comments. I'd love to know if any of my viewers work with this kind of machinery.